All right, these are going to be your notes for section 6.2, and this is on page 462. Please make sure that you are there. I know this first part is really just a vocab thing. We'll really dive into the examples, but it will help us out if something, we're looking at reflection. So a reflection, we talked about this, it's kind of like having a mirror. It looks the same, but it's also kind of flipped. And that's something that we really need to figure out. So if you look right here over the x-axis, so if you need to flip some, I'm sorry, not flip, but if you need to reflect something over the x-axis, your y coordinates are all going to be negative. So that's actually a very helpful hint. So I'm going to actually type it. If you have room on the side, which you do, go ahead and write it. Reflecting over x-axis, y is opposite. So what does that mean? If the y is already a negative, it's going to become a positive. Okay, so negative turns positive, and then positive turns negative. So they switch for the y. Now, on the opposite side, if we are reflecting over the y-axis, your x is opposite. So that means that, same thing again, negative turns positive, positive turns negative. These are things that are going to end up on your cheat sheet. But if you look right here on the example that is given, you can see, okay, this first triangle, the blue one, is now being reflected over the x-axis. So really it just looks like, okay, if I were to fold these up, they would match up. Same here if it's over the y-axis. So don't forget that y is vertical and x is horizontal. Now the next little part there is just the definition. It says a reflection is a mirror image of the original figure. It is the result of a transformation of a figure over a line called a line of reflection. And a reflection, each point of the pre-image and its image are in the same distance from the line of reflection. So in a reflection, the image is congruent to the pre-image. So what does that mean? They are congruent. I'm taking out all of the important words. I'm going to put in mirror image, which also means that it's flipped, right? It's like backwards, however you want to think about it. One more thing here. Both, what do you call this? Both figures or images, I guess would be a better word. Both images are the same distance from line of reflection. Now, you don't really have to write these. These are just more notes for me to put these on the cheat sheet because these are like the breakdown of a reflection. Okay, so for this next one here, this is number 1 at the bottom of the page. We have a triangle A, B, and C. It says blue one right here. Okay, and they want it reflected over. I'm not going to read through the whole thing. Go ahead if you want to. They are going to reflect it over the x-axis, which they say right here also. And they want you to find the coordinates of the vertices, which means you need 3 different answers. So, and they do a good job of breaking it down. So it says point A is 2 units above the x-axis. So you can say, okay, here's 1, 2. That's the halfway mark. Go 2 more. 1, 2, and I put a dot. Same for B. I can count 1, 2, 3. That's the halfway mark. Count 3 more times, and I'm at B prime. Now for C, I only have to go once, so I go 1 time down. And then you guys can read those coordinates, and that's really what they want you to put as the coordinates. That's the answer that they're really, really looking for. And there's not an example with this one, but let's go ahead and read through 2. It says something about a quadrilateral, which means it has 4 sides. We're at these vertices. They want you to graph the figure and then its reflection. Make sure you graph the original image. That's what it's asking for. And we are going over the y-axis. So if you look here, and I start with the blue figure, K is 1, 2 from the y-axis, which means I go 2 more times, and I'm at K prime. Now for L, we are quite a distance from it, but I can count over 1, 2, 3, 4, 5, and then if I count 5 more back to the left side, we're at L prime, and they match up, and M's match up. So you need to make sure when you are reflecting, you know exactly which line that you are reflecting over. Okay, so here is like the real problem that you want to try it out. It says the figure at the right is reflected over the x-axis. X-axis is right here. And it wants you to find the coordinates of A prime and B prime, then sketch the image on the coordinate plane. I will let you guys try and sketch it. Me sketching never works out very well. So I'm going to start with A. I know that A is up here. I want to reflect it over the x-axis. So I need to count how far away point A, is from that line of reflection. So A is 1, 2 away from the line of reflection, which in this case is x. So that means I count down 2 more times, and then I put my dot. That dot represents A prime, and you put prime with a little 1. Same thing for B. I'm going to count down. Okay, it's 2. So I count down 2 times here. I put a dot, and that is B prime. Now feel free to fill in the circle, and I'm not even going to try. Make sure on here you pay attention to what the line of reflections are. This is going to be your example problem. This is actually from one of the books in your page there. If you look, it's number 1. It says graph the triangle ABC with vertices at A, B, and C, and you can read the numbers. And it's a reflection over the x-axis. So if you have a graph, you can actually show the reflection. And I put these points here. So the first one's going to be plot points if needed. Sometimes it might already be plotted for you, but we can go ahead and put A, which is at 5, 1. We'll go over 5, up 1. After that, we have B, which is over 1, up 2. And then we have C, which is over 6, and then up 2. So we kind of have a weird looking triangle here, which we can connect the points here. All right, now if we're actually doing a reflection, that means we need to move it, and we're just literally going to take it and reflect it across the x-axis. And the easiest way to do that, when you have a graph anyway, is just to count the distance. So I have a point here, and it is 1 away from, it's going down just 1 to the x-axis. So if I'm going to reflect it from that, I'm going to start from my x-axis and go down 1 time and put my new point right there. And I always stay on like the same line right here. I don't ever move that. Now on this one, it is 2 points from our line of reflection, which you can see right there. And then I'm just going to count down 2 more and put my next dot. Now this one over here, I count down and it's 2 from the x-axis, which means I go down 2 more. So if you see here, what I've done is just take my triangle and literally flip it over. Let's not do that one, that was too big. I just literally flipped it over the x-axis, and that's why it looks almost the same, but it's actually a mirror image of it.